सो हेलो गाइस, इस लेक्चर में स्टार्ट करते हैं जो हमारे ट्रांजिस्टर है उसकी वर्किंग। तो सबसे पहले हम लोग लेते हैं पीएनपी ट्रांजिस्टर। ठीक है, सो पीएनपी ट्रांजिस्टर, पीएनपी ट्रांजिस्टर। तो अगर मैं इसकी डेफिनेशन की बात करता हूं तो क्या डेफिनेशन निकल के आएगी वो समझिएगा। इन ए पीएनपी ट्रांजिस्टर n-type material is sandwiched into two p-type of material। ठीक है, सो डेफिनेशन की अगर बात करते हैं, इन ए पीएनपी टाइप, इन ए पीएनपी ट्रांजिस्टर n-type semiconductor material is sandwiched in between two p-type semiconductor material। ठीक है, इसी तरीके से अगर हम एन की डेफिनेशन दें, सो अगर एक पी टाइप जो सेमीकंडक्टर मटेरियल दैट इज सैंडविच इनटू टू एन टाइप सेमीकंडक्टर मटेरियल। क्लियर है यहाँ तक? सो वो एनपीएन की डेफिनेशन हो जाएगी। नाउ ये तो कोई छोटी सी बात, दैट इज कॉल्ड डेफिनेशन। ठीक है बेटा, नाउ हमें अब पढ़ना है वर्किंग। क्या पढ़ना है? इसकी वर्किंग पढ़ना है। तो वर्किंग को समझाने के लिए मैं दो डायग्राम बनाऊंगा। पहले तो एक से एक्सप्लेन करेंगे, देन इसको फाइनल करेंगे। सो ये रहा हमारा emitter, the left portion of a transistor is called emitter and the right portion of the transistor is called the collector and the middle portion of the transistor is called base। ठीक है, it is called collector, this is called emitter and this is called base। ठीक है, now emitter is also called anode, and sometimes it is also called anode, and the collector is also called cathode because it is always reverse bias and it is always forward bias, so it is positive, it is negative, that's why it is anode and cathode। clear है यहाँ तक? Now we are studying what material? P type BGT। okay, now first thing, in P type semiconductor material, holes are the majority charge carriers and the electrons are the minority charge carrier। Similarly, in case of n-type semiconductor material, electrons are the majority charge carrier and holes are the minority charge carrier। okay, now suppose we are having the holes as a majority charge carrier, so we are just drawing 10 holes, okay, and 2 as electrons. This is minority charge carriers। okay, so this is minority charge carriers, and the black bun is called the majority charge carriers, ठीक है बेटा यहाँ तक? सिमिलरली अगर मैं एन टाइप में बात करता हूं तो एन टाइप में क्या होगा? इट इज एन टाइप, इट इज donor type atom। ठीक है, so here we are having this is called free electrons, this is free electron and this is called holes। okay, so एक ही पेन का हम सारा लेते हैं, this is holes। ठीक है यहाँ तक? now अगर आगे हम बात करते हैं तो यहाँ पर जो है होल, जो इलेक्ट्रॉन्स है वो ज्यादा होंगे, इलेक्ट्रॉन्स आर more, okay, but the holes are less, okay। ठीक है यहाँ तक? now and this is heavily doped, it is moderately doped and it is lightly doped। ठीक है यहाँ तक? क्लियर है? नाउ अब जरा ध्यान से सुनिएगा। When holes are injected at the emitter side because it is highly doped, then maximum number of holes will move from emitter to cathode. Maximum number of holes will move from emitter to cathode through base region, through the base region. तो यहां हम लोग एक डायग्राम बनाते हैं, यहां पर एक और डायग्राम लेते हैं. ओके, सो फर्स्ट हम लोग जो ये वाला जंक्शन है इमीटर बेस जंक्शन, दिस इज कॉल्ड इमीटर बेस जंक्शन, इसको एनालाइज करेंगे. देन आफ्टर दैट वी विल सी द कलेक्टर बेस जंक्शन. ओके, सो दिस इज योर इमीटर, दिस इज योर कलेक्टर एंड दिस इज योर बेस. ठीक है, सो देयर विल बी concentration gradient or the electron and holes difference. ठीक है, तो अगर मैं बात करूं जो p टाइप है, जो इमीटर है, वहां होल्स ज्यादा है, बट n टाइप में होल्स कम है. सो देयर विल बी डिफ्यूजन ऑफ होल्स, क्लियर है. बट द मैक्सिमम नंबर ऑफ होल्स दैट इज ट्रेवलिंग फ्रॉम इमीटर टू कलेक्टर will reach, maximum number of holes will reach from emitter to collector, but some of the holes will catch up in the base region and recombine with electron and will disappear. फिर से सुनिएगा बात, maximum number of holes that is traveling from emitter to collector reached at the collector, but few 2 to 5% of holes are catch up in the base region and recombine with electron and disappear from this scene. ठीक है यहां तक. So अगर बात करें, holes are moving from this to this, so there will be emitter current, and this is called I of P of E. ठीक है यहां तक, because holes are moving from emitter to base. ठीक है. Now at the end side electrons are more, but at the p side electrons are less, so there will be movement of electron from base to emitter. So electron movement from base to emitter, this is I of N of E. P stands for the holes and N stands for the electron. Okay, I hope so ये चीज क्लियर होगी. Now since emitter base junction, this is your emitter base junction, that is forward bias, and the collector base junction is reverse bias, because we are assuming that the BJT is in active region. So to make BJT active, the N side, it is P side now, it is P side, N side, N. So P side should be positive, so it is positive, and N side should be negative. Is it okay? Clear, right? Done. So this is your emitter. Now since electrons are moving in this direction, then the direction of conventional emitter current will be from emitter to, or left to right side. It is left to right side, so it is emitter current. Is it okay with you? So it is, if you write, it is V of BE. Clear है यहाँ तक? Hope so ये बात समझ में आ रही होगी. Now this emitter current, the total emitter current IE is what? I of PE plus I of N of E. Now we know that the emitter is heavily doped, so the current due to the electron is very less, and the majority of the emitter current is due to holes. Clear? So we know that N of N, the electron concentration is very less as compared to the hole concentration. So I of P of E is very greater than I of N of E. So the total emitter current is due to the holes. So emitter current in PNP transistor, emitter current is due to holes. That is called majority charge carriers. Hopefully ये बात समझ में आ गई होगी आपको. majority charge carriers. ठीक है यहाँ तक. So I hope so अब आपको जो इमीटर की डायरेक्शन है करंट की वो बिल्कुल क्लियर हो गई होगी. Now when holes are traveling from emitter to collector by a base, some of the holes will catch up in the base region. Some of the hole will catch up in the base region and recombine with electron and disappear from the scene. Now holes is having positive charge. Holes is having positive charge. So it will be attracted toward the negative terminal of the battery. So the holes will move like that. So this is the hole. This is the hole's direction. If this is the hole direction, then the direction of base current should be like that. Like that. This is your base current. Because अगर हम बात करें जो conventional current है, that is opposite the flow of electron, but it is in the direction of positive charge. Okay, so base current is this. I hope so ये बात भी समझ में आ गई होगी अब आपको. So now we know the direction of emitter current, we know the direction of base current. Clear है यहाँ तक? Now next thing is what? Now when we are injecting the holes at the emitter side, then the maximum number of holes will reach at the collector side. Holes will reach at the collector side. So this is holes. This is holes. This is holes. Okay. Then holes will reach at this side. So this is the direction of holes now. Then the direction of conventional collector current. The direction of conventional collector current is also in this way. So it is left to right. Now the collector base junction is reverse biased. Now the collector base junction is reverse biased. So P should be negative. P should be negative. And this terminal, this base terminal should be positive side. Is it okay? So the direction of the collector current is this. The direction of collector current is this. Now if you see the collector current IC is due to majority charge carriers. Now what are the majority charge carriers? Majority charge carriers. That is what? Holes. Is it okay with you? No. Now since the collector base junction is reverse biased, then there will be a reverse saturation current due to the minority charge carrier, which is generated by thermal agitation. Clear? So simple अगर मैं बात करूं, the collector current is sum of the current due to the holes, due to majority charge carrier, or we can say majority carriers की वजह से होगी. Is it okay? But since the collector base junction is reverse biased, so there will be a reverse saturation current or the leakage current that is flowing from N to P. So there will be current ICO, that is called reverse leakage current or reverse saturation current. Okay, so due to the minority charge carrier, ठीक है. So एक जो total collector current है, that is due to the majority charge carrier and due to the minority charge carriers. ठीक है. Now suppose we have n number of holes at the emitter, n number of holes at emitter. Okay, then out of these n, 1 minus alpha times n is recombined at base. Clear? With this आपके पास n number of holes है emitter side that you are injecting, then out of that 1 minus alpha into n times is recombined at base with electrons at base. Now but alpha n times is collected at collector. Okay, ठीक है. यहाँ तक is collected at the collector. So the total IC, the IC is what? Alpha times of IC. So alpha times of I. That means if you send 10 holes, then at the collector we get 9. That's the meaning. And one is recombined with electrons at the narrow base region. Clear है यहाँ तक? Now this is the current due to the majority charge carrier, that is called holes. अगर हम second component की बात करते हैं, then we have the ICO, the current due to the minority charge carrier, which is due to the thermal process. Clear है? So this is the total collector current. Now if you see this is your BJT surface. This is your BJT surface. This is your BJT surface. Now I just assume this is a BJT NP, sorry, it is PNP now. So it is PNP BJT surface. Then one current is in. And the IB is out. And IC is also out. Now if this closed surface is shrink to a node, if this closed surface is shrink to a node, then the direction of current and the representation is like that, IB and the IC. Now if you apply the KCL, so according to KCL, the algebraic sum of all the current at a particular node junction is 0. So I is incoming and IC and IB are outgoing. So IE is equals to IB plus IC. Now is it okay? Clear है यहाँ तक? I hope so. ये बात आपको समझ में आ गई होगी. So this is all about what your collector current, emitter current and base current. Clear है यहाँ तक? Now next thing is what? Since IC is equals to IC is alpha times IE plus ICU. Now there are two stories. If IC is 0, then IC equals to alpha times IE. Then alpha is IC upon IE. That is called current gain. Now if we are having 10 number of holes, if 10 holes are reached or collected at the collector region, then alpha is 1. That is the maximum value. Alpha is maximum value. But in practical system, in practical BJT, if we are having 10 number of holes, then either 8 or 9 is reached at the collector. So collector current is 9 and the emitter current is 10. So its value is 0.9. Then alpha is what? Alpha is 9 upon 10, that is 0.9. So in general alpha is less than 1. That is 0.952, 0.98 value. Clear? And this alpha is mainly depend upon the temperature. And collector to base voltage. Clear hai yaar? Now next thing is what? If emitter is open, then I is 0. Then IC is equals to ICU. Now if you see the picture, if emitter is open, then the current obtained at the collector base emitter open, then it is called ICBO. So when emitter is open but the collector base junction is reversed by the current is only due to the minority charge carrier, or the junction is reverse bias. That's why this current is also called the reverse saturation current, which is the strong function of temperature, and this current doubles for every 10 degree centigrade increase in temperature. क्लियर हो गई यहाँ तक मेरे हिसाब से बात? सो आई होप सो जो पीएनपी ट्रांजिस्टर है उसमें आपको बहुत सारी चीजें समझ में आ गई होंगी ना. अगर मैं इसके कंक्लूजन की बात करूं, we have two type of transistor, PNP and NPN transistor. In case of PNP transistor, if you see, in case of PNP transistor, the emitter and the collector and the base, all these current are due to the diffusion process, and all are due to the majority charge carrier, and the majority charge carrier are the holes in case of a PNP transistor. But if you choose the NPN transistor, then all the emitter, base and collector current are due to the diffusion process, and these are due to the majority charge carrier, but the majority charge carrier are the electrons. क्लियर है यहां तक ना? Then next difference is what in PNP and so in PNP the current is due to the holes, in NPN the current is due to electrons. Clear है यहाँ तक? The next difference is what? The mobility of the electron is very high as compared to the holes. That's why we prefer NPN transistor as compared to the PNP transistor. Now the NPN transistor provides better frequency response as compared to PNP transistor. That's why we are using NPN transistor. क्लियर है? सो NPN और PNP के बारे में मैंने काफी कुछ बता दिया. PNP की पूरी PNP जो PNP ट्रांजिस्टर है उसकी जो वर्किंग है, कैसे हम करंट्स को कंसीडर करेंगे, कलेक्टर करंट, इमीटर करंट और जो बेस करंट है, वो सब कुछ मैंने आपको लगभग बता दिया. अब अगर लास्ट में एक चीज मैं समझता हूं यहां पर थोड़ा सा, अगर डायग्राम की बात करें, सो दिस इज योर इंजेक्टेड, सपोज दीज आर the injected holes, these are the injected holes, these are the here are the injected hole, we are injecting injected holes. Then these injected holes will travel emitter to collector via base. Then some of the holes will diffuse here, diffused holes with electrons. अगर आप ग्राफिकली बनाना चाह रहे हैं, but if you are having 10 holes, then one is diffused or recombined with electrons, then we are getting some holes that is called collected holes. ठीक है? So in this way you can also show your injected holes, the diffused hole and the collected holes to get clear concept of a current as well as the moving charge. क्लियर है? सो ये PNP ट्रांजिस्टर की वर्किंग यहां तक होप सो मेरे हिसाब से आपको समझ में आ गई होगी. जो अब न्यूमेरिकल्स आए हुए हैं उनको हम करते हैं.